Hello everyone, my name is Rasel Ahmed. My ID is 1230804 I want to talk about what is flip-flop. Flip-flop is a term that comes under digital electronics, and it is an electronic component that is used to store one single bit of information. Since flip-flop is a sequential circuit, so its input is based upon two parameters. One is the current input and other is the output from previous state. It has two outputs, both are complement of each other. It may be in one of two stable states, either 0 or 1. There are many kind of flip-flop which are SR flip-flop, JK flip-flop, D flip-flop and T flip-flop. Now we want to know about RS flip-flop. The RS flip-flop is used to store binary information. It consists of two inputs, set and reset. In RS flip-flop, R stands for reset and S stands for set. The flip-flop keeps its present state even when one or both inputs are deactivated. The flip-flop enters the 0 state when the reset input is activated and the 1 state when the set input is activated. We can construct RS flip-flop with two ways. One is with NOR gate and other is with AND gate. Basic block diagram of RS flip-flop. The basic block diagram contains S and R inputs, and between them is clock pulse. Q and Q prime is the complemented output. RS flip-flop circuit with NOR gate. In figure 5.5, an RS flip-flop containing two NOR gates has been illustrated. It should be remembered about NOR gate that its output is 1 only when all of its inputs are 0. And when any one or both of the NOR gates inputs are 1, its output is 0. Operation when both inputs are 0. In the situation, NOR gate's inputs have no influence whatsoever on its output as long as the input condition of flip-flop does not change. As such, flip-flop term remains on its present or normal state, i.e. no change occurs in the value of Q, which has been illustrated by the first line of its truth table. Remember that if S input becomes 1 for a moment, flip-flop moves on the set state. Similarly, if R input goes 1 for a moment, in such a situation, flip-flop shifts to the reset state or a clear state. When value of R is 0 and value of S is 1, in such a situation output of the bottom NOR gate becomes 0 or low. As output of bottom gate is an also input of the top gate, in this way both inputs of the top gate become 0 or low. Resultantly output of the top gate becomes high or 1. As such flip-flop sets when input S becomes 1. Remember that when flip-flop output Q is 1, this stable state of flip-flop is called set. This has been demonstrated by two second line of the truth table. When R input is 1 and S input is 0, the output value of top NOR gate becomes 0 or low. As the output of top gate is an input of the bottom gate, hence both inputs of the bottom gate become 0 or low. As a result, high output is obtained from bottom gate. Therefore, applying on or R input, flip-flop resets on a stable state, which is known as the clear state or reset state. When both inputs are 1, a forbidden state prevails on flip-flop. RS flip-flop circuit with NAND gate. In figure 5.5a, a basic RS flip-flop circuit consisting of two NAND gates has been depicted. It must be remembered regarding NAND gate mechanism that when both of its inputs are 1, its output becomes 0. Operation. When both inputs are 0, then both outputs become 1. This state is called forbidden or a prohibited condition. According to second line of the truth table, when S input is 0 while output input is 1, then in such a situation output Q becomes logic 1 and output Q becomes logic 0. When S input is 1 and R input is 0, output Q becomes reset. This condition is also known as clear state as has been illustrated by line 3 of the truth table. When both inputs are 1, in such a situation both outputs retreat onto its previous or last condition. Resultantly, no change substantiates. Now we talk about clock RS flip-flop. The clock flip-flop uses two AND gates A and B at the input stage, and common input of both AND gate is named as clock. This two AND gate will supply as an input S and R to RS flip-flop to overrate when and only when clock is high. If clock is low, using an don't care condition of AND gate R and S input becomes 0, disabled to provide input RS flip-flop. Now we talk about what is JK flip-flop. Unlike the JK flip-flop, the basic RS NAND flip-flop circuit has many advantages and uses in sequential logic circuits, but it suffers from two basic switching problems. The set S is equal to 0, reset is equal to 0 condition must always be avoided. If set or reset changes tie while the enable input is high, the correct latching action may not occur. Then to overcome these two fundamental design problems with the RS flip-flop design, the JK flip-flop was developed. The simple JK flip-flop is the most widely used of all the flip-flop designs and is considered to be a universal flip-flop circuit. The two inputs level J and K are not shortened, abbreviated letters of other words, such as S for set and R for reset, but are themselves autonomous letters chosen by its inventor, Jack Kilby, to distinguish the flip-flop design from other types. The sequential operation of the JK flip-flop is exactly the same as for the previous RS flip-flop with the same set and reset inputs. The difference this time is that your JK flip-flop has no invalid or forbidden input states of the RS latch even when R and S are both at logic 1. The basic JK flip-flop, both the SR and R inputs of the previous RS bistable have now been replaced by two inputs called the J and K inputs respectively after its inventor Jack Kilby. Then this equates to a J is equal S and K is equal to R. The input AND gates of the gated RS bistable have now been replaced by two 3-input NAND gates with the third input of each gate connected to the outputs at Q and Q prime. This cross-coupling of the RS flip-flop allows the previously invalid condition of SS1 and RS1 state to be used to produce a toggle action as the two inputs are now interlocked. The truth table for the JK function. Then the JK flip-flop is basically an RS flip-flop with feedback which enables only one of its two inputs terminals either set or reset to be active at any one time under normal switching, thereby eliminating the invalid conditions seen previously in the RS flip-flop circuit. While this JK flip-flop circuit is an improvement of the clocked RS flip-flop, it also suffers from timing problems called race if the output Q changes state before the timing pulse of the clock input has time to go off. Thank you very much.